The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Stop. Menopause. This week on Science for the People, we're talking about what happens when fertility stops. We'll speak with Lynnette Sievert about the theories behind why menopause even happens at all. But first, we'll talk to Lauren Drogos about menopause symptoms beyond the hot flash. Welcome to Science for the People. I'm Bethany Brookshire, science writer at Science News and Society for Science in the Public, and we are here for part 2 of a 2-week series on women's health. Last week, we covered issues that can arise in a woman's body after birth. This week, we're looking at what happens when those fertile years end. Because I don't know about you, but when I learned about the female reproductive cycle, I learned that, hey, these are the hormone changes that happen. And then in menopause, they stop. And you get hot flashes. But it turns out it's a lot more complicated than that. And here to talk us through it is Lauren Drogos, a cognitive neuroscientist at the University of Calgary. Thank you so much for being here, Lauren.
Oh, thanks for having me.
So first of all, to give people a reminder, I was wondering if you could do a brief overview of what happens during an adult woman's ovulatory cycle. What does the ebb and flow of hormones in there look like?
Yep. So the main female hormones are estrogen, progesterone. And kind of what happens is that as you're going along in your cycle, so day 1 of your cycle is the first day of the start of menses or bleeding. And that during that time, both estrogen and progesterone are low. And then what happens is that as you go through, your levels will slowly creep up. So your estrogen levels and progesterone levels will get higher. You'll ovulate, and then your progesterone levels will sort of take off a little bit, which are what can cause some of those nasty premenstrual symptoms. So things like bloating and feelings of tiredness. And then after that, your estrogen and progesterone levels drop, and that's when your period starts all over again.
Great. And then, as I learned, during menopause, this stops. But it doesn't stop immediately. It's not like an off switch. Can you talk a little bit about premenopause or perimenopause?
Yeah. So, most women are very, very shocked to hear that the best predictor or the best gauge of what's going on as far as if you're perimenopausal or postmenopausal, et cetera, has very little to do with your hormones. So we actually still use bleeding status as sort of the gold standard. And the reason for this is that as you're transitioning from what we call sort of your late reproductive years into the early perimenopause, your hormone levels start jumping all over the place. And so one day if we took your blood and measured estrogen and progesterone, they might be really high, but the next day they might be really low. So instead we measure when the last time you had your period was. So in late reproductive years, so this is when you're still pretty much regularly having a period, what starts happening is that, you're born with the number of eggs that you're going to have throughout your entire lifetime. And as you get towards this late reproductive stage, it gets harder and harder for your body to mature a follicle for your menstrual cycle to kind of continue. So there's this hormone called luteinizing hormone, and it's what triggers the follicle to mature. And as you're going through this late reproductive stage, your body keeps trying to blast more and more of this luteinizing hormone to get those eggs to mature into a follicle and have your period. But as you're running out of eggs, less and less are maturing, and sort of your body starts kind of, I'll say, stalling within the system where it can't actually get an egg to mature. And at that point is when you're going to see things like skipped periods. And so as you're going through, your hormones actually can kind of be a little bit wonky. And that's because your body's actually trying to start this sort of feed forward cycle of the menstrual cycle, but it can't really get the engine started, so to speak.
So that's when does this happen? Like, how long does this whole thing take between this whole, like, kind of trying to start the car and the car is not quite going or it's going every other time, to when the car's battery is just gone.
Just gone. So that's the one thing, is that we consider anything before the age of 40 a premature menopause. But as far as the length of the perimenopause, so this is the time period where you'll be skipping periods, or you'll have those hormonal fluctuations that aren't sort of a normal menstrual cycle. It can be very variable. So some women will just suddenly stop having their periods and everything was hunky-dory before that, or some women will have a sort of a long transition period of 5 years, 8 years. I'm pretty certain that the norm is about 3 years, and the average onset in North America of menopause, and that's complete cessation of periods for at least 12 months, is age 51.
Wow. And what kind of symptoms are women getting over that 3-year period between average age of 47, average age of 51? Very, very average. What kind of symptoms are happening?
All sorts of symptoms. So the main reported ones in Western culture, number one is hot flashes. After that, you're going to get sleep complaints. And then after that, you're going to get memory complaints or changes in cognitive abilities.
And what is a hot flash?
So a hot flash is sort of this esoteric thing. Weirdly enough, we don't actually know what the instigating trigger of each individual hot flash is, but it's a short period where the body actually has a vasodilatory response. So what this means is that suddenly women will experience an intense sensation of heat, usually starting at the chest, and then it sort of emanates up into the face, and then perhaps down into the arms and lower body if it's really, really bad. Women can also get sensations of tingling. Oftentimes there'll be a lot of sweating associated with hot flashes, but these usually resolve within about 10 minutes.
Wow. So you do sweat, and
Yes.
your body is definitely hot. This is not a
Yes.
And you also, your work talks about vasomotor symptoms. What does vasomotor mean?
It's just a very fancy word for including hot flashes and night sweats. So when these events happen during the day, they're hot flashes, but you can also get them exclusively at night, and that's what we call night sweats. So night sweats tend to be, when they wake women up, tend to be pretty bad, where women will be soaking sheets with sweat and that kind of stuff.
Glorious. And we've got no idea what causes this.
No. Well, I mean, we know that it's associated with removal of estrogen from the system, but as far as, the triggering event that causes each individual hot flash, we have no clue.
Charming.
Yes.
And so you sent me a bunch of papers, and we will be posting links to the publicly available ones on our website. But one of the things that surprised me when I was reading your work is that women going through menopause and perimenopause do have these complaints after the hot flashes and the sleep disturbances about their memories. And I thought that maybe this was an aging thing, that just kind of everyone was like, oh my God, I'm old, my memory is going. But apparently not. What's going on?
No. Yeah, so that is one of the issues that we come up against, is that most women ascribe changes in memory and attention to the aging process. So I'm getting a little older, that's why it's a little bit harder for me to remember things. But as women transition through the menopause, they seem to get this sort of temporary hit. So I'm not talking where, they're going to be needing to go to the doctor for, severe memory complaints, needing, follow-up or anything like that. It's more on the scale of, if I were to give you a list of 25 words before and after menopause, you might be able to remember 17, but during menopause, you might remember only 16. So it's these small changes to memory and attention that women pick up on, but they're not really big enough to be, something that we would consider to be clinically relevant. So you're not going to be sending people to the memory clinic for these changes. And as far as why they're happening, so we don't exactly know the the entire physiology behind this, but we think it also has something to do with the changes in hormones in the brain. So one thing a lot of people may not know is that the brain actually has all sorts of receptors for the sex steroid hormones that fluctuate during your period and across a woman's life. So estrogen, progesterone, both of those. But estrogen seems to be really, really important, or at least there's a lot of receptors for estrogen in the area of the brain, the hippocampus, that controls memory or is involved in memory formation. So we think that may have to do with some of this. So kind of as women are transitioning through menopause, their estrogen levels are dropping or kind of bouncing all over the place. And the cells that are usually very happy getting their, monthly dose of estrogen and chugging along suddenly are no longer receiving that input. And so that could be one of the reasons why we see these changes.
Well, and I was wondering, you mentioned that they also complain, that's kind of the third complaint after the hot flashes and the sleep changes. Could it be they're just getting really crappy sleep?
So that is potentially one of the things. So in one of the papers that we looked at, we were looking at objective cognitive performance. So this is when we take a woman into the clinic and we do, or into the lab, and we do basically a half day of cognitive assessment. So they're sitting in there with me doing little tests or games of memory and attention for about 4 hours. And what we found is that there seems to be separate contributions of the sleep disturbances and also of menopausal status. So yeah, they're definitely, they sort of, part and parcel go together, but it seems like there are two different components that are sort of unfortunately combining together to cause these changes.
And you mentioned a little bit that you go about studying these changes. I was actually wondering if you could kind of go into some detail on the kind of experiments that you do looking at hot flashes, hormonal tracking, and memory tests. Like what do you run these women through to study how this is working?
Oh, yeah. So I'm beyond thankful for any participant who agrees to go through a study with me, because they are, in some cases, pretty intense. So all of our participants, what we do is we go through sort of a tracking period where we make sure that either they're experiencing enough hot flashes or actually do have a cessation of menstrual cycle for a year or for 6 months, or kind of whatever we're hoping for our study. And then when they come in for the memory, so this is what we call sort of a standard neuropsychological exam or a standard neuropsychological tests. So there's a whole bunch of different tests that you can choose from. But usually how we go about choosing our tests is based upon previous research. So if something has been shown to be sensitive to changes in estrogen, and that's what we're looking for, we'll choose those tests. But so, for example, if we wanted to look at memory, there's a couple different memory tests that we could do. So one being, I read a participant a story, and then I ask them to tell me as many details or as much of the story as they can remember immediately, and then after about a half an hour delay. There's also sort of list learning tasks. So this is kind of classically what you think of as a memory test. I read you a list of 25 words, and then ask you to tell me as many back as you can immediately, and then again after some delay. But we'll also do things that are a little bit not necessarily what people would think of when they think of memory, and give them a geometrical design and then have them copy that down, and then have them try and reproduce that completely from memory. There's also other things like spatial memory tests of, we'll flash a dot up on the screen and you need to tell me exactly in what quadrant it was, those kind of things.
And during this whole time, you're also taking their blood and tracking their hormones?
Yeah, so usually when they come into the lab, the first thing that we do is a blood draw. So yeah, we'll use that to track their estrogen and progesterone levels. One of the other things that I do occasionally is that we can sometimes use saliva instead of blood, and I think most people tend to be very appreciative of that.
And do you compare them to women who are completely postmenopausal? Do you compare them to women who are, fully reproductive, like in the, much younger women? How do you kind of compare them to other people?
I mean, it really depends on the study design. So a lot of the ones that I have been involved in have been looking at women who are in this late perimenopause transition into early postmenopausal. So about 6 months without having a menstrual cycle to about 3 years after their last period. And what I'll do is compare women who are having severe vasomotor or those hot flash symptoms, comparing them to women who do not have them. So in general, the age of the women there is going to be pretty equivalent because we're just comparing between groups. But one of the neat things is that because 51 is the average, it doesn't mean that everybody's going through the transition at the same time. We can compare women who are about the same age who just happen to be at different points in their menopausal transition. So you can have a woman who's 51 who is still late reproductive, and you can have a woman who's 51 who is, postmenopausal, so hasn't had her period for over a year. So in some semblance, we have a very nicely set up natural experiment. So it really depends on the question that we're asking.
I'm really amused that you kind of ask them about the severity of their hot flashes. Like, do you have to turn people away and be like, I'm sorry, you're not suffering quite enough to be included in our study?
I have. It's really sort of unfortunate where I'm like, oh, you're just not having enough hot flashes. And most women are just absolutely aghast. Like, you can have more? Like, oh yeah, you can. But if we're doing a hot flash study, usually what we do is that we screen people in with a diary. So using what we call subjective hot flashes or hot flashes that they experience. And we'll give them a diary for 1 week, 2 weeks, and they'll just kind of track the number of hot flashes that they have during the day and at night. And depending, again, kind of on the study design, we'll say, yep, you meet our criterion, or unfortunately, you're not having enough.
I mean, some of them I can imagine would be kind of pleased.
Yes. Yeah, I mean, I do feel bad for the women who are just kind of like, wait, what? I'm not having bad ones? What's a bad one? Like, oh, well, sorry. And
what have you found so far about the hormone levels that you're tracking, the hot flashes, and memory function?
So the one surprising thing is that hormone levels don't actually seem to be directly related to any of this. So it's sort of an all or none phenomenon. So we know sort of in the big picture, hormones are very much related, but when you actually look at the individual numbers on a day or within a month, they're not necessarily predicting the women who are having more hot flashes or less hot flashes. And then when we sort of tie that all into women having more versus less hot flashes, we actually find that women who have more hot flashes are actually doing a little bit worse than the women who have fewer hot flashes on the tests of memory and attention. So that was surprising in some ways, but also kind of makes sense in others. And the one piece that we wanted to kind of follow that up with was, the women who have a bunch of hot flashes, is the reason that they're experiencing this just because that they're waking up in the middle of the night because of their hot flashes. And that doesn't seem to be the case. So there's something physiologically going on with the hot flashes that is causing these changes in attention and memory performance. And we're not really certain what it is yet.
And it's not just a matter of routine forgetfulness, like, oh, I forgot the grocery list. This actually could have something to do with dementia, right?
Sort of long term. So it's a little bit hard to say, it's very hard to say, and it's not necessarily a causal link or anything like that. But we think that changes in the brain sort of that happen in midlife are what set up people to be at higher or lower risk of dementia. So dementia is sort of this weird, not weird, but very difficult thing to predict who is going to wind up with dementia or not, because there's certain people who have the genetic risk factors, who have other risk factors, who sail through the rest of their life and never develop dementia, versus others who only have a couple risk factors who actually wind up developing dementia later on. But the idea is that if we can find different predictors or different markers in midlife or earlier in life, we can set people up to reduce the other risk factors that they have in developing dementia. Does that make sense?
Yeah. Okay. But we should also note that, as you've mentioned kind of earlier, hot flashes are miserable. They're really awful. Menopause sucks. Yes. People will do anything to try and mitigate their symptoms. But hormone therapy for a long time, giving people some estrogen, progesterone, combined estrogen treatments was really hot. Now it's kind of really become unpopular. Why?
So there's something called the Women's Health Initiative. It's a very, very large study that was undertaken. I actually don't know the inception date, but sort of through the late 90s, early 2000s. And what happened was that the trial had to be ended early because they found that the estrogen and progesterone arm, when given to women, was increasing risk for negative events. And this got picked up by the media something fierce.
And by negative events, what do you mean?
I'm going to chalk this up to my own personal sleepless nights. I want to say it was cardiovascular and stroke, but I'm not 100% sure, so I'm just going to say negative events.
It's okay. I'll find some links and put them in the notes.
Okay. Thanks. This was very much picked up by the popular media, saying hormone therapy is going to increase your risk of death, or all of these horrible outcomes, and it scared a lot of physicians. It scared a lot of women, but sort of, 5 years later, 10 years later, when we kind of, hindsight looked back at the trial, it may not have been the best design to answer the question that we were actually trying to ask. So the Women's Health Initiative enrolled women later in life. So these women, in some cases, were in their 70s. So they were receiving estrogen and progesterone treatment potentially 20 odd years after their body had last seen estrogen. The one thing that we do know about estrogen is that it does increase risk of thrombotic events. So meaning that it makes your body more likely to throw a clot. So this can increase your risk of, when you're younger, things like deep vein thrombosis, where you get a blood clot in your leg, or somewhere else in your body. But later on in life, it can also increase your risk of things like a stroke or potentially a myocardial infarction or a heart attack. So in these cases where women were older, their bodies just may not have been equipped or used to handling estrogen back on board. And so not surprisingly, these were the women who actually did worse off. But when you looked at the younger cohorts of women, so women who were in their 50s or potentially in their early 60s, when we broke it down either by age, and by we, I mean the royal we, I didn't actually do this work. When you broke the data down by age, or when you broke the data down by years since menopause, those who were closer to the age of 50 and those who were closer to the last year of their last menstrual cycle, were more likely to see a benefit than a harm from the hormone treatment. The sort of annoying thing is that this isn't really exciting news. So that piece of information wasn't really taken up by the media. It's more fun to have a splashy headline of, increases your risk of death, versus if you take it when you're younger, it's good, or it can be helpful. So a lot of women started turning towards non-hormonal therapies. So things like soy treatment, and black cohosh, red clover. But the other piece of that is that we also don't have a lot of research on what those do. So it's been sort of a large fallout from that study.
I would just like to note a major media pet peeve of mine. Nothing can increase your risk of death. We're all going to die. I really hate headlines that say increases risk of death. No, it doesn't. Your risk of death is 100%, always.
I actually, for some reason, the risk of death isn't what gets me. I always chuckle when say, like, increases your risk of mortality. And I was like, oh.
We all have a 100% mortality rate. I really hate to tell everybody this.
I'm glad I'm not the only one. Every time I see increases risk of mortality, I'm like, oh, that is earth-shattering.
A 200% risk of mortality. Wow. Yeah, it's just
right.
Anyway. So I digress. But you mentioned that people are turning to these alternative kind of therapies, soy, red clover, black cohosh. These all have, they're not estrogens. They're often phytoestrogens. They have estrogen-like properties. They bind to some of the same receptors. And women do take them to relieve these symptoms. And you've actually been involved in a stage 2 clinical trial to look at some of these alternative therapies. So how'd it go?
So the trial itself, we were looking at efficacy in cognitive complaints and also in hot flashes. And kind of what we found is that not such great news for the phytoestrogens, that they weren't really doing much. So caveat being that this was a pretty small trial, but we didn't see large benefits for taking any of these phytoestrogens for memory performance or for hot flash reduction.
Oh. How did they compare to the hormones? You did actually compare them to hormone treatment.
Yeah, so hormone treatment is extremely effective at reducing hot flashes, but compared to the hormone treatments, it just wasn't anything. And the other thing is that in the short trial, there really wasn't much of a signal for boosting memory performance for the hormones either.
Oh, it's too bad. It feels like there's not really a lot out there.
Yeah, well, we're definitely still going to keep looking. But as far as we're as far as actually what's going on, we're not no immediate hope.
And one of the things I noticed in your research, and well, it kind of struck me mostly just how surprising it was, because a long portion of women's lives is perimenopause and menopause and pre-adolescence. You spend way more time not menstruating than you do menstruating. So like if a woman lives till the average age of say 80 and she's fertile from 15 to 45, that's only 30 years out of those 80. But it seems like we don't know a lot about the other 50 years. Why is that?
I wish I had a good answer, but I can spout some very pessimistic and perhaps not so nice theories about why women's health isn't at the forefront. But in general, one of the things historically, women's health research has definitely trailed behind. Some of this having to do with a bit of a paternalistic view of medical research that, we need to protect women from potentially exposing them to drugs that may hurt them, partially sort of fallout from drugs that can do damage during pregnancy, but also sort of long-term. In general, it's one of those things where it was often spoken of as if menopause was not that big of a deal, kind of historically.
It sounds like kind of a big deal.
Yeah. Like it definitely throws most women for a bit of a loop. There can be some really terrible sort of symptoms as you're transitioning, and Yeah, again, that comes back to me being with the sort of pessimistic explanations of previous generations. There weren't very many female physicians, female researchers, and therefore if you don't experience it, you're less likely to perhaps want to go into that area of research. But kind of one of the things that I always tend to start my talks with about menopause is that 50% of the population goes through this. And even if you're not part of that 50%, your significant other, your sister, your daughter, somebody who is close to you is likely to go through this. So why don't we care? Yeah.
And finally, I have one last question. It's kind of a non sequitur, but I think you're the person to answer it. Lately, I've been finding things on the internet about how in this day of your menstrual cycle, you're extra organized. On that day, you're more creative and organize your whole life around this constantly fluctuating well of hormones. 4 days after ovulation is your best day on the treadmill. I really literally saw this. So you can be your best self and write the next great novel if you only write it on, every alternating 12th day of your hormonal cycle. Is any of this true? How much should women blame on their cycle when it comes to changes in their behavior and function?
Yeah, so I haven't heard those things specifically as far as them being backed up by research. I haven't seen anything on that. As far as changes that happen across the menstrual cycle there are changes in physiology that happen across the menstrual cycle. There are changes in cognition that happen across the menstrual cycle or in brain function. But these changes oftentimes are much smaller than what you'll see if you get a bad day of sleep. So while these changes and differences do exist, in general, it's not going to be enough that, on X day of your menstrual cycle, you're going to, write the next great American novel versus if you just try and write it the next day, it's not going to happen. Most of the... it's just a funny concept to me, but it's probably not true. Probably not true.
Well, Lauren, thank you so much for coming on the show and not letting the hormones get us down.
Well, thank you. Happy to be here and always happy to talk about menopause.
We've linked to more information about Lauren Drogos and her publicly available work at scienceforthepeople.ca. Next up, every culture has its differences, and those differences run deep, including differences in how different cultures experience menopause. We'll be speaking with Lynnette Sievert about her research looking at menopause across cultures. Don't touch that pause button.
Science for the People is a weekly radio show and podcast that explores everyday life from a scientific perspective. We are a member of the Skeptic Network, a collection of blogs, podcasts, and video content focusing on science and critical thinking. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to support us at Patreon, to connect with us on Facebook and Twitter, and to subscribe to the podcast in iTunes. And now, back to the show.
Welcome back to Science for the People. I'm Bethany Brookshire, a writer with Science News and Society for Science in the Public. And please be advised, for this interview, I have a terrible cold. So I appreciate your patience, and I'll try to get through this without coughing horribly. Now, being raised in a Western society as I have been, menopause hasn't been something that I've heard or talked a lot about. Until today. We've already heard a little bit about some of the symptoms of menopause that go beyond the hot flashes. But where does menopause come from? How long have women been waking up with night sweats? What's it for? And how do other cultures handle this phenomenon that occurs among women of a certain age? Here to walk us all through it is Lynnette Sievert, a biological anthropologist at the University of Massachusetts at Amherst. Lynnette, thank you so much for making time for us.
Oh, thank you. This is nice to be here.
Now, to start, humans are actually not the only species that goes through menopause, but it is pretty rare, right?
It is rare. I mean, every mammal has the capacity to go through menopause. Every female mammal has the capacity because menopause happens whenever we run out of the eggs that are in the ovaries. And all mammals make all of their eggs all at once in utero, and then dole out those eggs slowly over the course of the lifespan. For most mammals, they die at or before the time that they run out of eggs, so you don't see a menopause. You only see a menopause whenever you have a mammal that lives beyond the egg supply. And there are probably 30 mammals that do that on a somewhat regular basis, but humans are one of the longest-lived mammals that go beyond the menopause, and the other mammal that lives way beyond their menopause are the orcas, the type of whale, and the short-fin pilot whale. So two kinds of whales and humans share that characteristic of a long life after the eggs are depleted.
But there are a few examples of primates, right? They don't necessarily live as long, but there are some primates that go through menopause?
Yeah, there's some work that shows that the macaque is probably our best primate model. The macaque is an old world monkey, so it isn't the closest relative to us. Chimpanzees are closer, gorillas are closer, but somehow the macaque is more like us in the slow loss of eggs across time and the capacity to live beyond the egg supply. But there we're talking about menopause by the age of 25, and then they may live another 3 or 4 years. So it isn't a very long span afterwards. And the evidence for chimpanzees and gorillas is mixed. It depends on the population of chimpanzees. Some have found what looks like a menopause, and others haven't. And in gorillas, there was a really nice study that was done in zoos all over the United States where they were looking at the progesterone levels in the feces of the older female gorillas to see if they were still cycling. And at the age of 48, some of them were, some of them weren't. At the age of 50, some of them were, some of them weren't. I think that was about the top of the age scale. So you didn't see this universal menopause like humans have. I mean, we are universal. By the age of 60 or 62 maybe at the outlier, all women are done menstruating. And you just don't see that in other primates except perhaps for macaques.
And in a review that you wrote about menopause, you noted that the phenomenon, we don't see it in chimpanzees. We see a little bit of it in gorillas, but not really. But you noted that menopause probably goes back evolutionarily hundreds of thousands of years. What do we know about where menopause arose in our evolutionary tree?
Well, there's work that's done to make estimates of our lifespan. See, one of the problems is we don't know if menopause was always around 45 or 50. And 50 seems to be the average age of menopause in high-income countries. In high-income countries, you get menopause at 50, 51, 52. In low-income countries, you get menopause around 47, 48. So it may be that in our evolutionary past, age of menopause was somewhat earlier than it is now. So what we're looking for are individuals who lived past 40 or past 50 to say, yes, those females had menopause. But we can't always age skeletons really well enough, especially if you're going back to Homo erectus or Homo ergaster or other hominins back in our evolutionary past. So what we have to do is we look at, for these, they're called allometric relationships, where we're looking at proportions. And you can actually estimate lifespan by looking at the proportions of the body. and looking at when the molars erupted and the teeth and so on, and you can come up with a really good estimate for how long that individual or that species would have lived. And then you have another extra problem of you can look at maximum lifespan potential or average lifespan. And here we're interested in the maximum lifespan potential of what is our capacity to live. I mean, right now our capacity is 120 years, which is 70 years beyond menopause. That's our capacity as a species. And if we go back in time, maybe 1 million years, we can see that our capacity to go past menopause was there. But that doesn't mean that any females or many females lived that long. It may be that their average lifespan was 20. And there's good evidence that it was probably 20. But you may have had the odd individual way back in time who was able to reach that capacity. And we know from skeletal evidence that did happen in archaic Homo sapiens. So our own species, but 100,000, I don't know, 100,000 years ago, and I'm being a little loose with my number there, or with Neanderthals. We know that about 10% of Neanderthals lived long enough to have had a menopause. So whenever you go to a physician who says, oh, well, we have to do something about this because menopause is new. We didn't really have a long lifespan or an expected lifespan or an average lifespan until somewhere in the 20th century that made menopause a medical issue. You have to just say, no. You're talking about life expectancy. You're not talking about the maximum lifespan potential. And if you look at the maximum lifespan potential, we've had the capacity for menopause for a very long time. And even if you go to a museum, like if you go to Philadelphia and you go see the mummies and you look at these mummies that are thousands of years old and how old the females were. I mean, these are the rich, the wealthy who were well taken care of, and they're living into their 70s and into their 80s. So we have had this capacity for a very long time. Menopause is not new to our species or even to our genus. It's not new. It's just that now more women have it.
So when you're looking at these, say you're looking at Homo genuses, that are, hundreds of thousands of years old. You're mostly looking at fossils, you're looking at bones. How do you look at something like that and say, this person was old and went through menopause? Is there a way to look at bones and determine that menopause happened, or are we guessing?
Well, I don't know about going way back in our genus. But I know that there have been anthropologists who have looked at the bone for evidence of osteoporosis, and they've used osteoporosis as a marker of menopause, because if you look at the downward trajectory of bone loss, we just go down, 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 and then you hit menopause and it goes way down really fast, and then it sort of evens out again and goes down, down, down. And so there have been anthropologists who look for signs of osteoporosis in these skeletons going back 100,000 years or 50,000 years, and showing that's a marker for menopause.
And, of course, we know that we do go through menopause. I mean, that's pretty obvious. And there are a lot of hypotheses as to why. Some of them seem really depressing to me. I was wondering if you could talk a little bit about the old egg hypothesis, which is what I'm calling this particular hypothesis, the old egg hypothesis of menopause. Yeah.
Well, like I was saying, all mammals, make all the eggs they're ever going to have very early in the lifespan, usually in utero. There's some evidence that there are some mice that can continue to make eggs for a little while, but it's still early in the lifespan. And so then these eggs just sit there in the ovary and they sit there frozen in meiosis, in the very first stage of meiosis. So they're not even fully eggs yet, the egg that will be fertilized. They're just sitting there. They still have to go through all of this genetic change. And they sit there for 40 years, or they sit there for 45 years. And the reason that as women get older and they have more miscarriages is in large part because there are more genetic mistakes that happen whenever the meiosis starts up again, and the chromosomes get pulled apart. They get pulled apart wrong, badly, and there are more mutations, and there's just more mistakes. So some people have argued that the reason we have menopause is to protect women from giving birth to children with these birth defects, because it's better, according to this hypothesis, it's better to invest in the healthy children that you already have, even if that means being postmenopausal, to avoid having more children that would require more care and may not live to adulthood to have more children, more grandchildren for the woman.
And there's another hypothesis that is also kind of depressing, I think, called the maternal death hypothesis. Can you talk a little bit about that one?
Well, and this is, if we go back to thinking about Homo ergaster and Homo erectus in our evolutionary past, we've, Magdalena Hurtado and other people have done the math to show that with foragers, hunters, gatherers, foragers, that the children need their mother until they're about 5. And so if a woman continues having children up until she dies, that last child isn't going to survive. Maybe the last 2 children aren't going to survive. So back when the probability of death was very high early in the lifespan, the idea is that, and this is a hypothesis, but the hypothesis is that it's better to just stop having children and raise those children to adulthood, or at least beyond the age of 5. Because at 5, they can hunt and gather for themselves. Maybe not hunt, but certainly gather for themselves. I guess I don't see these hypotheses as quite as depressing, because they're just sort of looking at how long did people live, when are our eggs made, how do the eggs sit there in the ovaries, and they're just sort of taking this matter-of-fact evolutionary perspective that the most important thing from an evolutionary point of view is getting genes into the next generation.
That's a much more positive way of looking at it. When I was reading the papers on this, I kept thinking, oh man, my eggs are growing old and shriveling, and what if I died? It all sounds really awful, honestly.
Yeah, well, I don't know. I think from evolutionary theory, we're not always thinking about people, individuals, and households. We're thinking about it from a species level.
But now we get to the most famous hypothesis for why women go through menopause, which is also, it's also, I think, the most optimistic. It's called the grandmother hypothesis. Can you kind of run us through the grandmother concept?
Mm-hmm. Well, I think this is the most popular hypothesis because we love our grandmothers. I mean, it sort of taps into this emotional response that these postmenopausal grandmothers, now, and remember, we're talking about menopause at 40, 45, 50. So these women are now 45, 50, 55, 60. They're still relatively young. We're not talking about women in their 80s. So we're talking about a 50-year-old woman who is a grandmother. And also, if you think about having children at 15, you're a grandmother at 30. So we're just talking about an early grandmotherhood. So these women are still vigorous. And Kristen Hawkes is the person who really has developed this hypothesis. And she has the most amazing photograph of a Hadza woman in Africa using a lever to raise an enormous boulder so that she can get to the roots underneath, to get to the tubers. And she's doing this for her grandchildren. And she's this wiry woman. I don't know if she's in her 40s or in her 50s, but she's just this wiry, strong woman. So the idea is that these grandmothers are providing a lot of food for the grandchildren. That allows their daughters to have more children. So these women are getting more grandchildren. And you count your evolutionary success not on just how many children you have, but on how many children and grandchildren and nieces and nephews and whatnot, and great-grandchildren. It's an extended family is how you count your evolutionary success. So these grandmothers are postmenopausal because they can have greater extended family success if they invest in the feeding of their grandchildren rather than continuing to have children of their own.
Now, we've talked through three of these hypotheses, and there's also a hypothesis that menopause might help, prevent cancer. How much support is there experimentally, observationally, for these hypotheses? Is there, what kind of support do we have to back up any of these?
Well, the support for the aging eggs hypothesis comes from the increase in chromosomal abnormalities with the age of the mother. And that's what they draw on, and then they come to the conclusion, better to just cut it off. For the aging mother hypothesis, there are mathematical models, and the mathematical models are testing how many children and grandchildren and so on does a woman have if she stops her own reproduction. And just as in the same with the grandmother hypothesis, it's mathematical models that are testing this. I mean, one of the challenges to the grandmother hypothesis is that we do have historical data that we can use to see if places where the grandmother lived in the home had better infant health, and that's just measured as less infant mortality. And so there have been a number of studies that have looked to see if there's a grandmother in the house, are her grandchildren more likely to live? The challenge is we don't know what her behavior is. We don't know what she's actually doing in these homes. And these same studies show that the maternal grandmother may be a positive influence, but the paternal grandmother may not be. And the grandfathers may also actually be deleterious to the health of their grandchildren. And so then my question is, well, but how do you select for just maternal grandmothers? Because a woman can be the maternal grandmother of her daughter's children and the paternal grandmother of her son's children. You see how complicated it gets?
Yeah.
And we don't know, and we don't know what she's doing. We don't know, especially, and these studies are using data from historical populations, so we're not talking about gatherers moving boulders to get at tubers. So we don't know what she's doing to help.
So she could just be sitting around eating bonbons and, drinking gin and tonics. We don't know her life.
Well, I mean, it goes back a couple of hundred years, so I don't know about the bonbons. But
gin and tonics go back a couple hundred years.
Probably.
Now, we've been talking a lot about the biological contributors here. You are a biological anthropologist, but there are also cultural contributors that I found to be especially fascinating. And we're getting to the part of one of your reviews, I think, that blew my mind. It turns out that not all women suffer hot flashes, and in fact, in some cultures, it's very rare, and menopause isn't really a thing, culturally speaking. Why might that be? What are some of the examples?
Well, my most recent example is I did some pilot work in Odisha, so this is not a large sample. But I had an undergraduate here at UMass Amherst, Subrangi Swain, and she says, "Oh, Lynnette, you need to come to Odisha in India and you can stay with my grandmother and we can talk to women about their menopause. And I, of course, being an anthropologist, I always say yes. So I went, and we stayed with her grandmother and our other family members, and we talked to women in this tiny little village in India. And so we're saying, tell us about your menopause. And they would look at us and say, and talk about their menstruation, or talk about their breastfeeding, or talk about their childbirth. And we'd say, okay, that's great, interesting, thank you. Now tell us about your menopause. And they would just look at us because they had nothing to say. It was such a non-event in their life. And it became sort of funny because here we were coming from the United States looking for something that they didn't have to offer, in a sense. And we only met one woman who even had an idea of what we thought of what hot flashes are. And, even what we learned in Bangladesh is that when we describe hot flashes to a study participant, we need to be careful. Because in Bangladesh, they would say, well, what do you mean by hot flash? And there the words were Goram Vap Laga, something, that's what it looks like on paper. Goram Vap Laga. It means feeling steaming hot. And we would motion, well, it's sort of here, sort of in the center of the chest. It goes up your neck and it involves the face. And they would all just look and nod politely at us. And then we had them draw on a body diagram where they felt their hot flashes. And 68% of the women put their hot flashes on the top of their head. And here in the United States, we almost never talk about hot flashes on the top of the head. But they actually also talked about hot flashes as the feeling of smoke coming from the top of their head. So they were experiencing these hot flashes differently. And we found the same thing in Mexico. I was putting hot flash monitors on their chest, and here they were feeling the hot flashes on the back of their neck. So now I put hot flash monitors on both the chest and the back of the neck. So some places have no hot flashes, and I'm convinced that was what we found in India. And some places they're having hot flashes, but they're not the same experience that we expected. That these hot flashes have a cultural component, and in Bangladesh it's probably because they cover their heads. Because these are 80% of the women were Muslim, so they cover their heads with a scarf. And the Hindus also cover their heads with a scarf, sometimes out of politeness, sometimes because prayer is being called, but that traps in the heat. So it's actually partly cultural that they feel the hot flashes differently than we do.
That's so wild to me that a culture can actually influence a biological symptom like that. And it's not just the hot flashes, right? It's also, memory and things like that. There are other symptoms of menopause that people experience differently.
Yes. And that's what we see when I go to Mexico. Well, this is when I was working in Puebla, Mexico. I work now in Campeche. But when I was working in Puebla, I would ask women, what do you associate with menopause? Just open-ended. And they would say in Spanish, bone pain. And I'd say, bone pain? What is bone pain? And they'd say, well, it's like when you're getting the cold or a flu and you just ache all over. That's what you get with menopause. And I thought, isn't that interesting? Because they never, ever volunteered depression. And they almost rarely talked about hot flashes, too, although when we ask about hot flashes, they had hot flashes. But it was this bone pain that was more important to them, or something that they remembered more often. So, yeah, we get very different symptom frequencies across cultures.
Well, Lynnette, thank you so much. I'm so sad that we're out of time because this is amazing. Thank you so much for being here.
Well, thank you for the opportunity. It's been fun.
We've linked to more information about Lynnette Sievert and her work at scienceforthepeople.ca. While you're there, you can check out our links to Twitter, Facebook, iTunes, SoundCloud, and Stitcher. You can follow us, like us, or give us a friendly review. You'll also find options to donate. We are an all-volunteer effort over here, and your monthly donation can help keep us going, calling up scientists, and delivering you awesome conversations. If a donation isn't in the cards, that's okay too. Leave a review or tell your friends about us. Spread the science word. Thanks for listening, and we'll see you next week on Science for the People.
Science for the People is produced by Rochelle Saunders and edited by Ryan Bromsgrove. Helen Quivalon is our publishing liaison. We get research help from Josh Witten and consulting support from Desiree Schell. Our frequently seen guest hosts are Marion Kilgour, Anika Hazra, and Jessica Yaros. Our theme song is called Binary Consequence, and it was written and recorded by Fractal Pattern. Science for the People is entirely listener-supported. You can find us on Patreon, where you can support us with monthly donations in any amount, or you can send us a one-time donation in any amount via the donate page of our website. Science for the People is created in partnership with the Skepchick Network, a collection of blogs, podcasts, and video content focusing on the intersection of science, popular culture, politics, and social justice. You can find out more about Skepchick at skepchick.org. The show is hosted by science news writer Bethany Brookshire and me, Rochelle Saunders.